We know from Newton's first law that inertia is an inherent property of a body which opposes the change of state of rest or uniform linear motion. So we know in uh, in Newton's first law of motion, inertia is a property which opposes the change of state. So there is two kind of change of state. Change of state. There is two kind of change of state. One is rest to motion, and another is motion to rest. In exactly the same manner, a freely rotating body about an axis, suppose this is a rotating body about an axis, this is the axis of this rotating body. X of x prime is the rotating axis of this body. So, suppose this body is freely rotating about an axis x to x prime. So if this body opposes any change in its state of rest or uniform motion, in other words, we can say that it possesses inertia of rotational motion. So here from this theory, we can say that inertia is moment of inertia is something like that which opposes the change of rotational motion. So let us take an example to understand it very clearly. This is a wheel A and this is a wheel B. This is a wheel A and this is a wheel B. As uh, this wheel A has the longest radius than wheel B, so we can say that the radius of A is greater than radius of B. So which wheel will move faster? Which wheel will move faster? So if we will go to the definition of inertia, we can found the moment of inertia of a body about about an axis can be defined as the sum of the product of the mass of each particle and the square of its distance, the axis of rotation. It is so and it is given by I, which is equals to summation of mr square. So now we will discuss what is this mr square. Suppose it says that it is the sum of the product of the mass of each particles. So we take some particle. This is particle m1, this is m2, this is m3, this is m4, and of each particle, and the square of its distance, the axis of rotation, and the distance of axis of rotation is this, 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 this. So this is the distance of this each particle m4 to this rotation axis xo x prime, and we will uh, uh, we will define m1 as the distance of this m1 particle is r1, that will be r2, that will be r3, and that will be r4. So it says that the inertia is equals to the summation of all the particles. So there are suppose n particle consisting this rigid body m, that the mass of this rigid body is m. So and we can say that summation of m1 r1 square, because this says that the mass of each particle and the distance axis of rotation is square of the distance is square of its distance, the axis of rotation. So you can say that m1 is the particle, r1 is the distance between m1 particle, and it will and the square of this represent the inertia for m1 particle. For m2 particle, that will be m2 rt square. For m3 particle, it will be m3 r3 square. How much it will be go? It will be go for mn rn square. So we can represent this whole thing as summation of mi ri square where I equals to 1 to m. I equals to 1 to m, or we can simply represent this as I equals to m r square, m r square. So here we can find that when the radius is greater, the inertia will be higher. When the mass is greater, the inertia will be higher. Inertia will be higher. So according to this concept, we can say that as the radius of A is greater than of radius of B, so the inertia of A of I of A will be greater than inertia of I of B. So we know inertia opposes the change of state. As A has more inertia, the wheel A has more inertia than wheel B. So the A wheel will be moved slower than wheel B. So this is the whole concept of moment of inertia, and the formula of moment of inertia is I equals to mr square. So we have to remember the basic definition of moment of inertia and how this inertia helps in our day-to-day life. This is the main concept of moment of inertia. Then coming to the second one, which is known as radius of gyration. So what is the definition of radius of gyration? It says that it is a distance of a point from an axis of rotation such that if a point equal to the mass of a body, so this is an important point. If a point equal to the mass of a body is placed at this point, so that means suppose this is our body and this is the axis of rotation. This is the axis of rotation. Suppose we denote a point if this point has a property. It says that if the total mass of this rigid body, we can consider this total mass in that point. So we say that we can consider this point to have the total mass of this body, or we can say that we can consider this point as holding the total mass of this body. So suppose the total mass of this body is capital of M, and we pointed out this point where we can place all of this mass of this body, and so we find out a point equal to the mass of a body is placed at this point. Its moment of inertia about the axis of rotation is equal to the moment of inertia of the rigid body about the same axis. So that means it says that if we find out the moment of inertia of this point, so what is the for this particle for this point, we know the moment of inertia is m, and suppose we represent this distance from axis is k. So this is suppose k, and we know moment of inertia is mass into distance from axis of rotation square. So we can write this thing as m k square, and it says that this mk square, the point of this inertia is equal to the point of the inertia of the whole body. So if we find out the whole inertia of the whole body, so suppose we have to find out the inertia of this rigid body, then we will use the formula m1 r1 square, m2 r2 square, m3 r3 square dot mn rn square for different point. Up to n point we will find out this inertia of this whole body. It says this inertia of this whole body is equal to the point we placed and the distance of this point to axis of rotation is square, or we can say that this point of for that point, if I say that this is a P point, this is a P point, the the moment of inertia for this P point is equal to the moment of inertia of the whole body. Moment of inertia of the whole body. If this is happened, if we find out the point of inertia, if we find out the point where we can place the mass of the whole body, here in our case this is the P point, then this K, the distance from this point and from the rotation of axis is known as radius of gyration. So here our K is known as radius of gyration. So K is equals to the radius of gyration. So this is the concept of radius of gyration. So again we consider the whole definition. It says that it is a distance of a point from an axis of rotation. So we find out the distance of a point of axis of rotation. Distance of a point from an axis of rotation, we find out this distance of a point from axis of rotation. Which point? If a point equal to the mass of a body, and we found P point where we can replace the mass of the whole body in the point P. And it says that its moment of inertia about the axis of rotation is equal to the, so for this P point we calculate the moment of inertia about this x prime axis is equal to the, and this moment of inertia is equal to the moment of inertia of the rigid body. So this the moment of inertia at P point will be equal to the moment of inertia of the whole body. Then we can say that the distance of a point, so you can say the distance of a point from an axis of rotation is known as radius of gyration. So for radius of gyration we can use K equals to root over I by m. So this is the formula for determining the radius of gyration. That's all for today's video. These two concepts are very important to solve mathematical problem, to solve practical problem, to know how the laws of circular motions happen, what is the inertia, what is the radius of gyration. These two concepts are very important. So please understand this concept very clearly to understand the next part very well. That's all for today's video. Do subscribe to our channel. Thank you.